Hi everyone, today we want to show you on how a series resonant circuit works. First of all, this is the circuit given. So this circuit contains the source voltage, the resistor, the inductor and the capacitor. So by using Kirchhoff voltage law, the equation is negative Vs plus Is multiplied by R plus j omega L plus 1 over j omega C is equal to 0. Next, we arrange it, we get Is equal to Vs over R plus j omega L plus 1 over j omega C, where we know that Z is equal to the impedance is equal to R plus j omega L plus 1 over j omega C, and we arrange it, we get the Z in polar form, where Z equal to R plus Jx. Therefore, the Is is equal to Vs divided by Z. Next, in order to find the frequency response of the circuit's current magnitude, the magnitude of Is is equal to the modulus of Is is equal to the modulus of Vs over Z, where the modulus of Z is equal to the square root of R squared plus X squared, equal to square root of R squared plus omega L minus 1 over omega C squared. So we get Is equal to Vm over square root of R squared plus omega L minus 1 over omega C squared. Next, using MATLAB, this is the code. We let Vm equal to 20 volts, C equal to 10 farads, R equal to 5 ohms, L equal to 15 henries. Hs is equal to the transfer function, where omega naught is the resonant frequency, Q1 and Q2 is the quality factor, and B1, B2, B3 is the bandwidth. So we run the code, we will get the graph of transfer function Is against the frequency omega. In order to prove that, we using MATLAB, the answer given that the resonant function is 0.0816, the quality factor is 0.2449, and the bandwidth is 0.3333. So in the graph that we can prove at the maximum of the graph, it shows that the x is 0.07743 is actually approximate to the answer calculated by the MATLAB is equal to 0.0816. After that, next, we change the R equal to 3 to find the second quality factor, and we run the code again. From here, we notice that the graph, compared to the previous graph, this graph is have a higher amplitude than the previous graph. So the calculation is, now the resonant frequency is 0.0816, the quality factor is equal to 0.4082, and the bandwidth is 0.2. So from the graph, plot it as the maximum value. So the x is 0.07743, also approximate to 0.0816. Next, we proceed to find the third quality factor. So we change the parameter of R equal to 7. The other variable will remain constant. Then we run the code again. We found that the graph is smaller than the two previous graphs. And let us check about the answer. So the omega naught is equal to 0.0816. The Q1 is 0.1750 and the bandwidth is 0.4667. So compared to the graph, using the same method, we found that the x is 0.07531, which is also approximately to 0.0816, the resonant frequency. So what is the function of the series resonant circuit? The circuit is designed to operate at or near its resonant frequency, and the circuit acts as a filter such as AC main filter, noise filter, as the transfer function of the circuit can be highly frequency selective. And this circuit can be used in many applications such as the selective tuning circuit of radio and television for receiving different frequency. After that, after we have found the three quality factor, we compare it. The first initial quality factor Q1 is equal to 0.449. The second quality factor is equal to 0.4082. And the third quality factor is equal to 0.1750. By comparing three quality factors, we can conclude that the best selectivity of the circuit is Q2, which its value is the highest among the three quality factors. So what is the selectivity? The selectivity of an RLC circuit is defined as the ability of the circuit to respond to a certain frequency and block all the other frequencies. The best selectivity have the highest value of quality factor and its bandwidth is the smallest. Hence, the best selectivity is required for radio and television to receive a certain frequency and block other unnecessary frequency. So, thank you for watching.